Okay, so we're done with the binomial theorem for right now anyway. Just to kind of let you know what's going to be happening in the next couple of days and into next week. I'm not going to see you guys tomorrow, so if you have the morning off, enjoy it. Uh, but on Friday, we are having what? We are having a quiz. Now, it's not over the binomial theorem. It's going to be over arithmetic and geometric series. Okay, so adding terms of a sequence. Make sure you know those formulas. Go back over your notes, all that good stuff. If you have any last-minute questions, come on in. Let me help you with that. That's on Friday. Now, next Thursday, the 18th, you have your what? You have your first exam. So I created it yesterday. I put it together. I did put 2 binomial theorem problems on there, and the rest of it's coming from parabolas. Okay, we are definitely going to be able to start circles before next Thursday, but we probably won't finish. So just to be on the safe side, I didn't include that. So those are the 2 items you're going to be able to find on your test. Okay, everything we've talked about when it comes to parabolas and the binomial theorem. Okay, any questions about what's coming up? Okay, well, we were talking about 2 days ago parabolas. The first day was pretty much, the definition. We went ahead and diagrammed a couple of these. There was a lot of vocabulary. We really haven't gotten to a problem yet. I just want to review a little before we get started. So the diagram on the right illustrates the definition. It's all the points in the plane that are equal distance from a fixed point we call the focal point and a fixed line that we call the directrix. So it's the focal point and the directrix that work together to determine what the shape of the parabola is going to be, whether it's wide or fat, something like that. So if I connect any point on the parabola to the focal point and that same point perpendicular to the directrix, it always creates equal distances. You'll notice I've got a couple here in red and green and purple, but I could do that an infinite number of times. Okay, it's always going to give me equal distances. Any questions on the definition? Okay, and then the other diagram over here is going to help you remember the distances. All of the distances within a parabola are based on one variable. What is that? Okay, p. The focal length, the distance from the vertex to a focal point, is p units. From the vertex perpendicular to the directrix, that's p units. Now, what do we call the line segment that's always parallel to the directrix, goes through the focal point, but stops at the parabola? That's the latus rectum. And remember, there were other names. You can call it the focal width, the focal chord, but I always refer to it as the latus rectum. So these points that are labeled EPLR, those are endpoints of the latus rectum. Remember, if it opens up or down, the left point is 1. If it opens right or left, the upper point is 1. How far a distance is it from a focal point to an EPLR? It's always 2p units. So the full length of that latus rectum is always 4p. Now, if the equation is written correctly, you should be able to see what the width of the parabola at the focal point is. And this is where we finished up on Monday. I gave you 4 equations and we were talking about them. So let's do the same thing here, kind of a little review. All right. So negative 16 times y plus 2 is equal to x minus 3 squared. So I want to do 3 things here. I want to identify what direction it's opening, what the location of the vertex is, and what the value of p is, the distance from the vertex to the focal point. Okay, so here's my first question. Is it written correctly? Is that coefficient negative 16 in the right location? Okay, yes, so why are we saying that? What did we talk about on Monday? There you go. That coefficient has to be in front of the non-squared term or group. The only thing allowed in front of the squared term or group is 1. So if it's not the case, you got to divide that over because you're not actually looking at the width of the latus rectum. Okay, so let's see here. Zach, what direction would this parabola open? Up, down, left, or right? Not sure? Okay. Erica, you want to help him out? Okay, it would open down. You're close. Okay, it's not down. Why left? There's 2 things that tell me that. Okay. Now, if it's a negative coefficient, we know it's got to open either left or down. So why are we choosing left? Or wait a minute, what'd you say, Erica? I'm sorry, it is opening down. I'm sorry, I'm a senior. Just forget what I said. It is opening down. So we chose down because not only is your coefficient negative, but x is squared. You're absolutely right. Sorry, that was my fault. My fault. Okay. I know it's very rare, but it does happen. Okay. Mr. West made a mistake. All right. Let's see. Let's go and move on to the next one so we can forget about that. Jasmine, what's the location of the vertex? Let's see if I get this right. Well, at least let's start here. Which value would represent h? Is it the 2 or the 3? Okay, so h is always with x, k is always with y, and we label the vertex as hk. There's just one thing we have to do with those values. We always take the what? Starts with the O. We take the opposite. So the vertex here would be at positive 3 what? Negative 2. And whether you're writing the equation or you're going to pull the vertex off the equation like we did there, you want to take the opposite. And it's just because the way our general form is written. Okay. Now what I'm going to go ahead and say here, because the coefficient is in the correct location, I'm going to go ahead and say that 4p equals 16. Now that's going to be a difference from the resource we're using because from my point of view, the negative simply tells me direction. I already know that it's opening down, so I don't need the negative. I'm just trying to find the distance p between the vertex and the focal point. In this case, it would be what? 4. Okay. It's going to be 4 units. Okay. So that one would actually turn out to be really nice to us if I wanted to go ahead and sketch it. Now, let's take a look at the next one. Let me erase this real quick. See if I can get this one right. Negative 6 times y plus 1 squared equals x plus 7. Is it written correctly? What's wrong with this one? There you go. What's in front of the squared group? A negative 6. The only thing allowed in front of the squared term or group is going to be a positive 1. So in this case, to put it correctly, I have to divide the negative 6 over. I'm still going to be able to tell the direction and the vertex, but I won't see the true value of 4p unless I put it in the correct position. So y plus 1 squared equals, because there's a 1 in front of this group, negative 1/6 x plus 7. Okay. So this one, the actual lattice rectum should only be 1/6 of a unit wide. Okay, that represents 4p in this case. So we're talking about a pretty narrow parabola. Okay, what direction would it open? This one would open left, yes, because y is squared and the 4p is negative. What's the vertex? Negative 7, negative 1. And in this case here, I'm going to once again, because it's in the right position, set 4p equal to 1/6. So how far a distance is it from the vertex to the focal point? 1/24. Okay, so if you were going to sketch this, I would definitely, make your increments much larger because they're going to be very close together otherwise. Okay, so does everybody remember what we did the other day? Any questions about the values we got, where we got them from? Okay. Well, let's use this information. Let's start getting to our first problem. So the problems today I'm hoping are going to be pretty easy, not too challenging. We'll probably have a much more challenging problem on Friday because I'm going to go ahead and have you complete the square again. Speaking of, has anybody had the opportunity to look over the completing the square notes or watch the video? Okay, well, we are going to talk about completing the square today, so let's see how much you remember. But before we get there, here's my first example. X squared equals negative 8y. Okay, first off, is it written correctly? Coefficient is in the correct spot. It's got to be in front of the non-squared term. Now, I like to go ahead and include zeros if there's no values, because I always like to see a squared group and a non-squared group. So I could say x minus 0 squared equals a negative 8 times y minus 0. But that's just a personal preference of mine. You don't have to do that if you don't want to. Okay. So because I can tell that H is 0 and K is 0, I know the vertex is at 0, 0. So starting right here at the origin. Okay. What am I going to set 4P equal to? 8. There we go. That coefficient's in the correct location. So I know P is 2. Just divide through by the 4. So this one's going to be pretty nice to us. Okay, not too challenging. Now, what direction does it open? It opens down. X is squared, but the coefficient is negative. Now, because it opens down, once I have the vertex, I know I'm going to have to go down 2 units to get to my focal point. So if this is the vertex, that right there would be my focal point. Okay. In fact, what's that location? 0, -2. If I went down to get the focal point, I got to go up to get the directrix. In fact, I'm going to go the same distance, 2 up. But remember, the directrix is a line. So what would the equation of that line be? Okay, y equals 2. Y equals 2. Now, when it says focal width, it's just basically asking you what's the length of the lattice rectum. Okay, we can multiply P by 4, or, just go back to the original equation. We know it would have to be 8 units across. Now, the problem doesn't ask for it, but let's go ahead and find the EPLRs. EPLR1, EPLR2. Okay. So in terms of P, Alex, how far is it from a focal point to an EPLR? P, 2P, or 4P? It is 2P. So if P is 2, what's 2P? 4. Okay, so from the focal point, I've got to move horizontally 4 right and 4 left. So for this one, I'm going to go 1, 2, 3, 4 to the right. Which EPLR is that one that I just located? That's 2. If it opens up or down, the one on the right is the second one. It would be at 4, -2. Okay, I got to go 4 left to find the other one. 1, 2, 3, 4. So this is EPLR1. This is EPLR2. Okay, and you'll notice they are 8 units away from each other. Okay, which is exactly what we should be seeing. We have 3 points. We can create our parabola here. There we go. This one here was -4, -2. There we go. Okay. And there we go. That's everything we wanted to find. Questions? Jack.
Matter which point set you label as which ELR, like 1 or 2.
Well, we want to stay consistent. If it opens up or down, 1 will be on the left. If it opens left or right, then 1 will be above, 2 will be below. Just so we're all on the same page. Okay. All right. Easy, right? Nothing to it? Okay. Well, let's try this one. So while you guys try this one, we're going to do the same thing. Okay. Find all the information. Let's go ahead and find the 2 EPLRs and sketch a graph of it. While you guys are taking a look at that, I'm going to pass back your exit tickets. Okay. Yeah, so all in all, today should be a pretty easy day, hopefully. There's 8. Check. Ethan. Jasmine. Roughly. Are you part of Miss LHS? Cool. Like immediately after school or what? 5 o'clock. Oh, yeah, it's true. I know it takes me a while to get ready in the morning. I just can't do anything with my hair. Why are we laughing? Yep, there was a time when I had long, luscious hair. It was amazing. Brown. Then I started teaching high school, and here I am. Did I ever tell you guys the story that I almost didn't graduate because of my hair length? Well, I was a student of LISD as well, and for guys at the time, I don't know if they still have it. Are guys allowed to have long hair as well, or is there like a length? I guess there's no length, right? Yeah, Christian. Well, I don't know. He might be a rebel and just getting away with it. I don't know. I don't know what the rules are nowadays, but back in the day, guys couldn't have long hair or it had to be at a certain length. And I remember, I don't want to say the administrator's name out loud because I'm recording, but this was over at Monterey. We were in rehearsal in the auditorium for graduation because, at that time we didn't have the Spirit Arena. So we rehearsed in our auditorium. And while I was sitting there waiting for my turn, the administrator, bless you, comes up behind me, grabs a handful of my hair, and jerks my head back and says, "You're going to have this cut by graduation or I'll see that you don't get your diploma." And I said, "Okay." And back then, you probably couldn't tell now, I was kind of like a smart aleck and stuff like that. So I went and I got a trim. And I kept the receipt. He said cut. He didn't say how far. He just said cut. So I had the receipt on me while I was graduating. And he didn't bother me. I had it in a ponytail. But it was, who could I compare it to? I definitely did have it as long as Christian's. I would say probably about equal length to Erica's. It was pretty long. A little bit of insight into Mr. West's high school days. What was that, Jack?
Oh no, there was a comment from a member of the class.
Oh. What was the comment? That's hot. It was hot. I mean, I'm not saying hot isn't attractive. I mean, during the summer months, it got really hot. Yeah, I don't see how girls do that because Anyways, we're going to veer off into a conversation I don't want to talk about. Let's get back to math. Here we go. All right. So what is the value of h? Okay, h is 1. K is -2. So the vertex is 1, -2. 1, -2 would go right here. And I'll label it once I get the whole thing drawn because you're going to notice these are going to be pretty close to each other. Now, 4p is what? Is 2 because that's my coefficient. It is in the correct location. So p is 1/2. Okay, so both the focal point and the directrix are only half a unit away from the vertex. Yes, Rafa? I'm sorry? Oh! That's strike 2. Okay. If I get another strike, I'll have to cut my hair before the end of the week. So I won't be able to teach again. Yes, ma'am. Oh, how do we find P? Well, are you okay with us setting 4P equal to 2? Okay, so in the equation, 4P is always the coefficient that you're given, as long as it's in the right location. So all I did was say 4P equals 2, and then I just divided through by the 4. Okay, and we'll see that with some other equations as well. Okay. All right, so here's my guarantee. Right now it's 10:27. We get out of here at 52. I will not make another mistake the rest of the class period. See, now, what happens if I do? Then I'm a middle-aged high school math teacher. There you go. You'll give me $5? All of you $5? You heard me say I was a school teacher, right? And I got 2 kids, so yeah. There you go, 1. All right. So let's see. If P is equal to 1/2, what direction does this graph open? Okay. I heard up. We have a positive 4p and x is squared, so it is up. Okay. So from this vertex, I'm just going to go up half a unit. So right here, that's my focal point. Okay. So what would the location of that focal point be? 1 what? 1 negative 1.5. Okay. Or you can go ahead and say, 1 negative 3/2 if you wanted to go ahead and keep the fraction. Okay. Because I know we all love fractions. Now, we went up to find the focal point, so we're going to go down a half unit to get the directrix. And there we go. And what would that be? Okay, but what's the equation? Okay, y equals negative 5/2, or y equals a negative 2.5. Okay. All right. Now, in order to find the EPLRs, we need the distance of 2p. So we know that p is equal to 1/2, so 2p would equal 1. Okay, so from the focal point, all I want to do is move horizontally 1 right, 1 left. So 1 to the right, 1 to the left. Okay. So what is the location of EPLR 1? Remember, that's the one on the left. 0, negative 3/2, or negative 1.5. What's the location of EPLR 2? 2 and then negative 3/2, or negative 1.5. Okay, 3 points is more than enough to see what my parabola looks like. Okay, so this is the vertex. This is EPLR 2, EPLR 1. And you notice, especially in a graph like this, if it's very condensed, I'm not going to worry about labeling everything there because I have everything labeled over to the side, but I'm still telling you what point is which. Okay, and then the focal width, okay, well, we know by the equation 4p should be 2. Okay, how many people got all that correct? Okay, good, very good. That's a lot of hands going up. Okay. All right, let's try a couple here where we're going from the graph to the equation. Now, this one pretty much gives you everything you need, but if you're going to write the equation of a parabola, you only need 2 items. What do you think those are? You need the vertex for sure, and then one other item. Oh, no, not the direction. I mean, that does help with the form, but there's one other variable. P, we need to know the distance from the vertex to the focal point. Okay, so that I can get the coefficient 4p. Now, this one opens to the left, so which one's squared? X or Y? Okay, so I'm going to go ahead and say x minus h equals y minus k squared. So 4p would have to go where? In front of the x or the y? In front of the x. Remember, 4p always goes in front of the non-squared group, and is there something I'm missing? There you go. Because if I didn't put a negative here, the information would be correct. I'd start at the same vertex, but he would open to the right. So I need to make sure there's a negative there. So that's the form of the equation that I'm trying to write. Okay. So in fact, the vertex looks like he's at 2, negative 1. Okay. So h is 2, k is negative 1. How far a distance is it from the vertex to the focal point? Okay, it looks like 2 units. Okay. Now, like I said, this one pretty much gives you everything you need. Additional problems as we move on, I'll give you, maybe an EPLR and a directrix. Okay, maybe the direction and a focal point. But different bits of items where you should be able to work your way backwards and find what you need. Can anybody tell me what the equation is? What would the value of negative 4p look like? That'd be negative 8, negative 4 times 2, times x minus 2 equals y plus 1 squared. There we go. We know the vertex was at 2, negative 1. The focal point, we can see it's at 0, negative 1. What's the equation of the directrix? Okay, x equals 4. X equals because it's vertical. And then the focal width, we can tell here, from one EPLR to the other should be 8, and see that's exactly what I got in the equation. Okay. In fact, this one up top right here, would that be EPLR 1 or 2? That is 1. If it opens left or right, EPLR 1's above. Okay. Hey. Oh, if you were to write it like this, y plus 1 squared, I don't know why I did that, equals -8 times x minus 2. That is perfect because it's still equivalent. That's just the symmetric property. Okay. Okay. Any questions so far? Said it was going to be an easy day? Okay. And I haven't made a third mistake. No 3 strikes. Okay. Yet. I'm jinxing myself pretty bad here. All right. We got 2 problems left. Find the standard form of the equation for the parabola with the focal point at 4, 0 and directrix x equals 2. So see, this one does not provide you with a graph, and it just gives you a couple bits of information. This is basically what you can expect. Okay. So would you like a moment or two to try this one? Okay. At least try to figure out what the general form is going to be. See, I'm going to go ahead and write out x minus h equals y minus k. I haven't chosen a square yet, and I've got enough room in front of either to put 4p. Okay, so right now I'm just putting like the framework. So we need to decide what direction it opens, and that will determine what the form of my equation is going to look like. Well, since we're delving into the origins of Mr. West, or as Trump would say, the oranges of Mr. West. Anybody see that clip? It's actually really funny, even though he probably has something wrong with it. But anyways, I was talking to second period about this because during second period, Mr. Anderson came on the speaker and was talking about, I think between 11 and 2, the folks who are selling the caps and gowns are going to be here. So you can go talk to them if you're a senior, because really you can actually say it now. Next month, you walk across the stage. It's so close. But my advice to them was it's always fun at the end. You throw your cap up, yay, we graduated, and you're closing one chapter of your life, you're moving on to the next chapter, either going into the workforce or going to college, and things are going to change for you. But I remember at my graduation, there was already the issue I might not have gotten my diploma. Like I told you, he saw me. He didn't say anything to me, so either he thought it wasn't worth it, or maybe because it was in a ponytail, he thought it was short enough, whatever the case is. This was something different. At the end, when the ceremony was over, we all threw our hats up, yay! And I tracked my hat, watched it go down. This we were at the Coliseum, because back then, we didn't have the Spirit Arena yet, pretty old. But I saw the hat hit the ground, and I started making my way through people to get to my hat, and somebody picked it up and took off with it. So I still have my gown, but I do not have my original cap or tassel. Somebody took it. My guess is somebody threw their cap, lost where it went, and just said, oh, I'll just take this one and go. So for seniors, it's fun to throw your hat, but make sure you know where it's going to go and get it. Okay? And if you true, but see, that's what somebody else did, and now I'm in that position.
Well, then you do the same thing. Just grab it.
I didn't find another random one. I guess everybody else was able to keep up with it, and I didn't want to do that. Because I didn't want to put someone in a position years, down the line to be standing in a classroom somewhere, talking to students about their past. Saying I lost my cap. So see, now I'm in that position. Well, if it comes down to it, I think the right thing is not to make someone else feel bad if it's just me who's going to be affected.
You should have found his cap.
I just try to, I try to be a good person, treat others as I want to be treated. So I try not to look at it that way, like,
I think there would have been extra on the floor somewhere.
You think so? Or maybe there's someone who has 2 in their closet someplace. I don't know. Or maybe like you guys were saying earlier, maybe someone was looking at me with that long hair and was like, man, that's hot, and took my hat. And now just And now occasionally just thinks fondly of the billowing hair in the wind when they hold my cap. I don't know. Can you clone awesome? I mean, can you really reproduce perfection? Why are we laughing? Okay. Okay, we're getting a little off topic. Okay. All right, so help me out here. What direction should this open? Okay, so I heard left and I heard right. Okay, it's left. I heard left and right again. Well, let's go ahead and visualize it. The focal point's at 4, 0. So 1, 2, 3, 4. So here's my focal point. The directrix is x equals 2. And remember, the parabola will always open away from the directrix. They don't intersect, so it has to open right. So at the very least, we know y's got to be squared. 4p would have to go where? In front of the x. Because this one, because it opens right, we don't have to worry about a negative. So that's the form my equation should be taking. Okay. Now, if you go ahead and draw it out like this, you could just tell there's a couple of ways. You know that halfway between the directrix and the focal point, that's where the vertex always has to be. It's always got to be the midpoint between the two, right? Okay, so I can go ahead and say that my vertex is at 3, 0. Vertex is at 3, 0. Okay. Or, you know, if you're trying to do this in your head, if you don't visualize it, how far a distance is it from a directrix to a focal point? P, 2p, or 4p? From a focus point to a directrix is 2p, right? So if I know 2p is equal to the distance from 4 to 2, 2, see, I'm still getting 1 even if I don't have a graph in front of me to help kind of confirm that. Is everybody okay with what I'm doing? Okay, so I've got the value p, I've got my vertex. What is my equation? Okay, so you want to start with the y? So just y squared? Okay. Perfect. Okay. And you can include the 0 if you wish. You can switch the sides. 4 times x minus 3 equals y squared. There we go. How many people got that right? Okay, good. A lot of hands going up. Is there anybody who has any questions? If I'm not sure where we got a particular value. Okay. Last one. This is where we're going to take a general form and we're going to rewrite it in order to complete the square. So the one thing I'm going to want to do on Friday is when we come in, I'm going to go ahead and give you a more challenging one that has a leading coefficient other than 1. And then we'll go ahead and start taking a look at that quiz. But once we rewrite this into a form we're familiar with, we want the vertex, focal point, and directrix. Okay, so here's the thing. Will I complete the square with the x or the y? Okay, I'm going to do it with the y. The only way you can complete the square is if you have a quadratic term and a linear term. That is a y squared and a y. See, I have a linear x, but I don't have a quadratic x, so I can't complete the square with him. All right. So what I'm going to do, if there's any terms that I'm not going to complete the square with, I'm going to get rid of them. So I'm going to leave y squared and the 6y here. Now I'm going to put plus and leave a little bit of room because I'm going to complete the square in just a minute. So if I add the negative 8x over, that's 8x, subtract the 17. Okay. So 8x minus 17. Okay. Now there's also one condition, and I actually just mentioned it a second ago, what we're going to do on Friday. The only way you're allowed to complete the square is if what? The leading coefficient has to be what? A positive 1. If it's anything besides positive 1, you either have to divide it out or factor it out. I'm going to encourage you factor it out because when we get to hyperbolas, ellipses, circles, and circles are next week, you're actually going to be completing the square twice at the same time in one problem. Okay, but we'll get there. We'll get there. Okay, now does anybody remember how do I complete the square? Satish, what do you think? That's exactly right. You take the coefficient of that linear term. Let's just go ahead and call that b right here, because typically you see a lowercase b or some variable in your resources. But there's two things you want to do. You divide it by 2 and you square it. That is what we actually refer to as completing the square. Okay. Now, you'll always end up with a positive because you're going to square it. So whether it's negative doesn't matter. Negative 6 divided by 2 squared will give me what? 9. See, that's why I left a little bit of room here, because by completing the square, I'm going to get that value. But what am I forgetting? There you go. Whatever I do to one side, I have to do to the other side. The equation has to maintain that balance. Okay. Now, what we call here, by completing the square, by finding this number, you created a special type of trinomial. Does anybody know what it's called? Perfect square trinomial, yes. The reason we call it a perfect square trinomial is because of this. Let's say we go ahead and factor it. What two numbers will multiply to give me a positive 9, but add to give me negative 6? Okay, it's negative 3, right? Negative 3 times negative 3. But what do you notice about your two group factors? They're always going to be identical. If it's a perfect square trinomial, your two group factors will always be the same. Well, if you complete the square, you're guaranteed a perfect square trinomial. So what we're going to go ahead and do, instead of saying y minus 3 times y minus 3, we're going to say y minus 3 squared. Because remember, the equation we want, one side has a squared group, the other side doesn't. So see, we're already starting to get the form of the equation I need. What do I have on the right side? 8x minus 8. Okay. Why is that convenient, Jack?
Pull that boyo out.
Pull that boyo out. That is exactly right. See, here's the thing. We have the squared group, but we don't have a non-squared group. We do have to take that coefficient and pull it out. Right now, it's not correct to say that the vertex is 8, 3. Once I pull out that and it becomes the coefficient 4p, I have y minus 3 squared equals 8 times what? X minus 1. There we go. So see, there's my h, there's my k. See, there's the form of the equation we've been working with. So in fact, what's the vertex? The vertex would be 1, 3. What's the coordinate of the focal point? Because p is what? P is 2. Remember, 8 is my 4p. So what direction would this guy open? He's got to open right. So I know from the vertex I have to go 2 units to the right. So that would be 3, 3. Does anybody want me to sketch it out so you can see it? Okay. What about the directrix? If I went right to find the focal point, I'm going to go left to find it, so it would be x equals what? Or negative 2? Close. Negative 1. I'm just kind of curious, was that someone trying to trip me up to make sure I make a mistake? Or because it ain't going to happen. Sorry, I'm setting myself up for a big failure right now by doing that. Okay, there we go. Any questions? Now remember, this would be a completely different problem if I put something as simple as a 3 in front of that. You cannot complete the square until the quadratic coefficient is a positive 1. And that's what I'm going to go ahead and show you on Friday before we take our quiz. And then I'll probably go ahead and give you one to practice. Okay, perfect. I think that is the end of the notes, right? Yep, because after that, you get to the assignment. Good. Okay.
Pass out the assignment.
No, I will have it for you on Friday when you come in. I'm going to go ahead and wait. I'm going to, let you enjoy your